Why is this stupid? That's your problem, right? I think I'm doing it
Okay. Good afternoon. I hope everybody is doing well today. It's good to see everybody after the break. We're going to get right back to work. We're entering Chapter 8. I'm going to talk to you guys about Chapter 7 at the end of class. Also, I made some seat changes, so if you would please make a note of your new seat number, because the equity bars are in effect. And I'm going to be using the equity bars for number 1. Number 1, what did you get? I got student number 10, student number 3, and student number 13. Student number 10, what did you get?
-5 times a to the 6th power times b to the 12th.
Okay, student number 3.
-5 a6 b 15.
Okay, student number 13.
I have -125 a to the 6 times b to the 12.
So the correct answer is one of those. -125 a to the 6 b to the 12th. That's pretty impressive. It's the first person I've called on in all 3 of my classes that has gotten that question right, so that's pretty impressive. Let's go on to number 2, and we're going to talk about number 1 in a moment. Number 2, I'm just going to reveal the answers. I asked for ordered pairs. I put my answer as a table. You should have probably put ordered pairs, but it's the same thing. So here are the ordered pairs you should have had. -2, 6, -1, 3, 0, 2, 1, 3, and 2, 6. Number 2 is a review of ideas you already know and a lead-in for today. Number 1 is straight review of concepts you were supposed to already know. So let's spend a couple of minutes on number 1. So, it was definitely not easy. To try and help you remember and to possibly think through this, I'm going to actually change the question. So I'm going to wipe this out for a couple of minutes. And I want to change the question to I would like you to think about an approach to that. Just think about it for 10 seconds. Good. So, tell me, what would you do? Start with Marlon, Cameron, and then Raquel.
5 divided by 5 is 5 to the 3rd power.
Okay, Cameron.
Do 25 divided by 5, then multiply by the 3rd power.
Okay. Sorry, Raquel. You were going to say the same thing. So we could do 25 divided by 5, as Marlon said, and that would leave us with 5. But the 3rd power is still there. Then we would do 5 to the 3rd power. Okay. What's 5 to the 3rd power? Here? 125. Okay. So we end up with the results. Okay. But let's go back to the beginning, back to here. There is another approach. What is the other approach? And you have learned it this year. What's the other approach? Okay. I'm sorry? Well, where are you getting 25 times 5 from? This is a division symbol. So where are you getting 25 times 5? Okay, but what says that you can multiply them? Okay, okay. Well, there's another approach. It's a property that you learned. No recognition of what you do with this power that's on the outside of parentheses. What can you do with a power? Caesar, it's starting to come back to you. Go ahead.
It's a power of a product.
Okay. So what do?
So you do A times B.
Okay.
First two numbers.
Well, this isn't a multiplication problem. This is a division problem. But the same idea applies. So let's try to focus. So you're right. This is sort of like the power of a product, but it's a power of a quotient. And so what it means is that this power will be put onto 25, and that power will be put on 5. The power on the outside gets applied to everything on the inside. This is something you already knew. I'm sorry, you should be writing with your colored pen at this point. So if we take that approach, then we would end up with 25 to the third power over 5 to the third power. What would we have to do at that point? We need to keep simplifying until we have the final result. What could we do at that point? Selena? Beautifully said. So 5 to the third power, we can do that mentally. We already have it over here. That's 125. I can't do 25 to the third power mentally. Does anyone already have it done in their calculator? Go ahead. 15,625. Very good. Is that in simplest form? Okay, so let's now finalize it. What would we need to do at this point? Jamel? Good. So go ahead, do it. What does it come out to? Yeah, it does come out to 125. Okay? So, first, let me ask you this. Are you allowed to do what Marlon said? Are you allowed to do 25 divided by 5 to get this? Are you allowed to do that? Give me a thumbs up if you think you're allowed to do that. In other words, is it legal in this world of math? Some of you say yes, some of you are not sure. Good, put your thumbs down. Are you allowed to do this here, which is power of a quotient? Are you allowed to take each part of the quotient and apply the power to it? Give me a thumbs up if you think you're allowed to do that. Good, put your thumbs down. So some of you thought you could. Well, yes, you're allowed to do both of them. So let's call this the green path, and let's call this the blue path. Both are allowed. Both are legal. Which one would you do if I gave you a choice? Which one would you do, Juliana? Why? It seems easier. Good. What? Anybody else? Jamel, which one would you do? The green one. Why? The numbers are smaller. Okay. Just similar to what she said, but actually a little different. Marlon, you were the one who introduced this idea, so for you, instinctively, that's what you were going to do. Because it's more efficient. I love that. So, hopefully you see that they're both allowed, but one of them is much more efficient. Also, give me a thumbs up if you could do each step of the green path mentally. Yeah. Put your thumbs down. I even talked you through that. I even pointed out that I couldn't do that mentally. I definitely couldn't do that mentally. There was 2 steps in the blue path that I couldn't do mentally. So not only is the green path simpler, smaller numbers, you can do it mentally, but yet you get the same result. So now watch this. Let's go back to the original question. What approach did you take? Because my experience has been so far with many of my students that a lot of people try to apply the exponent to everything and either messed it up or it became very confusing. Or some of my students just had no idea. So let me propose this. What if I had written the question like this? What if I had written Would that have made a difference for you? I'll take it a step further. What if for the moment I just take away all this, I take away all this? What's that when you simplify? Kiara?
A to the second power.
So that's a to the second power. That by itself is not hard, right? Let's bring this back. What's that simplified to? Cameron?
-5.
-5. Let's bring this back. Leave that whited out for a minute. What's b to the 5th over b simplified to? If you're just sitting there doing nothing, you're not going to get anything out of it. Go ahead. B to the 4th. And then we had to the 3rd power. So now, if we do all of this to the 3rd power, isn't that a lot simpler than from here trying to apply the exponent to each factor of this expression? That is really complex looking, although you get the same answer. But if you can understand that when you have everything is being multiplied and divided, you can separate anything any way you want. When you have the same base, it's very easy. This really means A times A times A times A. This down here is A times A. That A will cancel that one cancels that one, and you get 2 of them left over. That's something we've spent time on. So now, again, I'm not trying to imply that this is easy, but at this point, now you've got, let me use a different color. You got to the 3rd power, power of a power right there, power of a power right there, but power of a power you guys know very well. So now you got -5 to the 3rd power, a to the 2nd to the 3rd power, and b to the 4th to the 3rd power. Someone remind us, power of a power, what do you do with the exponents? Power of a power, what do you do with the exponents? Can you multiply? Power of a power, a to the 2nd to the 3rd, a to the 2nd to the 3rd, power of a power. That's a to the 6th. Any questions or comments on number 1? So there's a bunch of review in here. There's a whole bunch of different properties happening at the same time. In fact, that constitutes about half a chapter right there. Any questions about that? Good. Let's talk about part number 2 very quickly. How'd you do it? How'd you do it, Kyle? Very good. So these are all the x values. That's what a domain is. And you take this number, you plug it in, and simplify. -2 squared is 4, plus 2 is 6. So the output is 6. Take the -1, plug it in. -1 squared is 1, plus 2 is 3. The output is 3. And each pair of numbers becomes an ordered pair. So you end up with -2, 6, and -1, 3, and so on and so on. Any questions about that? Good. Now we're ready for today. Of course, you already wrote down today's lesson is 8-1, part 1. Make sure you write down part 1. There will be a part 2. Part 1 and part 2 will be wrapped together as one grade and one lesson. You will get one homework assignment for both of them together. So, let's jump in. Today we start exploring quadratic functions. You've been studying polynomials for a while, so you've actually been studying quadratic. A quadratic is usually in polynomial form. So, we have 3 major goals today. 1, we want to be able to identify a quadratic function. by a few different methods. 2, and here's the big one. We're going to learn how to graph a quadratic function. And the third is, how can you tell whether the graph of the quadratic is going to open up or open down? Okay? So, what you see here is the first graph that you're seeing of a quadratic. This is the most basic quadratic function that you can write, y equals x squared. This is quadratic because the highest exponent is 2. That's one way to tell if it's quadratic. So you can put it in standard form, y equals ax squared plus bx plus c. The number in front of the x is the a, but only when it's in standard form. So this could be rewritten as y equals 1x squared plus 0x plus 0, and so it is in standard form. A is 1, b is 0, c is 0. And that is a quadratic function. You can also see that the graph is very particular. It forms a U. And we're going to talk more about that in a little while. So I want to pause here and I want to do a quick little, allow you a moment to explore. So I have a little app set up. And what you're looking at here is the same thing that I just had on the screen. This is a quadratic function. And it's actually set up here. This is a computer program, so there's certain things that have to be here. So this is going to stay here. This is quadratic because its highest exponent is 2. But I have these sliders here, and I can adjust this to see what happens to the graph. So make sure you're looking up here so you can see what happens. So first I'm going to change A. So let's see what happens when I change A. Watch what happens when A turns to 0. What happened to it? Hold off. Let me put it back to its original. So now this is y equals x squared. Let me change b. So let's see what happens when I change b. Let's see what happens when I change c. Notice what showed up here. Number showed up right there. That's c. So watch what happens now when I change a to 0. What happened to it? Could someone explain in words what happened to the graph? What happened, Caesar?
Straight.
Okay, Cameron?
It's linear.
Linear now. It went from quadratic to linear because the x squared term disappeared. And what Caesar said was correct, that it became a straight line because it became linear. This basically disappeared. So when I reintroduce a different value, it becomes quadratic again. Any questions about what you're seeing? I will have this app up on my website so that you can do your own exploration of what happens. Also, watch this. Let me put this back up a little bit. Now watch. Here it is back to 0. Watch what happens when I start making a negative. Any questions? Any observations? Caesar and then Jamel?
When you went into negative, like it went down and then it came up or something like that.
Do it again. So I'm positive, now A is positive 2. I slowly go to 0. Now it's 0. Now I turn to negative 0.1 and...
Oh,
Go ahead, Caesar.
The slope is is neat. Like,
Well, we don't. I understand what you're kind of indicating. We don't use the term slope because slope refers to a straight line. But yeah, you're right. Something's happening to the shape of the graph. We're going to talk more about that a little bit later. Okay? Absolutely. Jamel? Okay. Good. So now we're getting some ideas about what's going to be going on. So again, the 3 goals. We want to be able to identify quadratic. We want to be able to graph a quadratic, and we want to be able to tell if it's going to open up or open down. Guess what? You should already know one of the goals. You should already be able to tell how it's going to open, whether it's going to open up or down, but we'll talk more about it later on. Okay? Now, in the past, and you don't have to write anything at the moment, you just need to stick with me. A long time ago, we explored linear functions by looking at a table. And we did something just like this, where we figured out what the difference was in the x's. We looked at the differences of the y's. If the differences in the y's were all the same, that was called linear. So a linear function would have all of the first differences would be the same. But you can see here that they're not the same, which means that this is not linear. So how could you tell if something was quadratic? There's a different way to tell, well, along the same lines, there's something called the second differences. It's the differences of the differences. This is the first differences. Now if we take the difference from here to here, and here to here, and here to here, if that is constant, if that is the same, the second differences are constant, then it's quadratic. Excuse me for 1 moment. I apologize. Okay, so if you calculate the second differences, which is pretty much a little bit of mental math, then you can tell that something is quadratic. You can also tell because there's an x squared term. But we're going to explore situations where you do not have this bit of information. If this is not here, and we just have the numbers, how could you tell if that represents a quadratic? Okay? So, if the second differences are constant, then it's quadratic. Second differences are constant, then it's quadratic. Any questions? We're going to do this together, so I'm just introducing the idea. Any questions? So we now have 2 different ways to tell. We actually have 3 different ways to tell. One way to tell is if there's an x squared term. Another way to tell is if you have the graph and it forms a U, that's quadratic. That's 2 different ways to tell. The third way to tell is if the second differences are constant, then it's also quadratic. So let's explore those different situations. So, part A. Is this quadratic? Is it linear? Or is it something else that we don't know about yet? If you think you have an instinct about it already, go ahead on the side of your paper, write down what you think it's going to be. If you think it's going to be quadratic, you can just write down quad. If you think it's going to be linear, you can put line. If you think it's going to be something else, you can just put a question mark. If you want to take a guess, that's a good thing to do. See how your instincts are working. But now let's not use our instincts. Let's actually use some analysis. If we start out by checking the x values, what's the difference from here to here here to here, and so on. What's the difference? Julian? This is adding 1, that's adding 1, that's adding 1, and that's adding 1. Yeah, so it's adding 1 all the way. So that's the same rate. So now let's check the changes in the y. So we're going to check what is called the first differences. From here to here, and here to here. This is called the first differences. So what is happening from the -9 to the -2? Selena? Very good. I have a lot of students who were saying -7 in other classes. So that was very good that you caught that that's +7. You're moving positively. What about from -2 to -1? What's happening there, Kiara? You're adding 1. What about from -1 to 0? Kayla?
Oh, what?
Very good. We're adding 1 again. What about from 0 to 7? 0 to 7. Randy? You're adding 7. Very good. So the first differences are not constant. These are not constant. If this was linear, they would be constant. But they're not. So we now know it's not a linear. It's not going to make a line. So now we do the second test, which is check the second differences. And now we go from here to here, and here to here, and check those. So what happens from 7 to 1? What's the change there, Raquel? Very good. Subtract 6. What about from 1 to 1? What's the change there? Cameron?
Add nothing.
Add 0. Very good. Nothing. And what about the change from 1 to 7? Sam?
Bless you.
What's the change from 1 to 7? Very good. We're adding 6. So now we're looking at the second differences and saying, well, if it was quadratic, these would all be the same, but they're not. So our analysis has concluded that it's not linear and it's not quadratic. The question asked us to tell whether it is quadratic, so the answer is no, it is not quadratic. And it asks us to explain, our explanation is right here. The second differences are not the same. So no, it is not quadratic. Does anyone have any comments or questions about that? Go ahead, Julianne.
Maybe like second and like first differences. You only do that to like the y.
Correct. But first, and I'm glad you brought this up. First, make sure the x's are moving at the same rate. If that's not moving at the same rate, then don't even bother moving forward. This all has to be the same for you to do these two. So very good point that you brought up. And the differences are only done with the y values. So once you figure out that those are all the same, the x's, then you can check the first differences and the second differences. Very good. Any other comments, questions? Selena and then Marlon?
So if it's not a constant difference, that means it's quadratic?
Where? Here?
Like,
Here? No, these are, the second differences will be constant, will be the same. That will be quadratic. Okay? I'm sorry if I somehow confused you. This is not quadratic because these are not the same. This is all we're looking at. Okay? Marlon? Same thing? Okay, I apologize if I wasn't clear enough. Good. How can we tell if this is quadratic? Let's do it this way. Give me a thumbs up if you think that's quadratic. Okay, I got a few people who think yes. I got people not putting the thumbs up. Give me a thumbs up if you think this is cubic. Give me a thumbs up if you think it's linear. Okay, some people think it's linear. Okay, so, but the question is this quadratic? It can't be two different kinds. It's either linear, quadratic, cubic, quartic. It can only be one of them. So how can we tell? What are we looking for? Essence? That was it. She said that beautifully. If the highest exponent is 2, then it's quadratic. Otherwise, it's something else. What's the highest exponent in this one? Jamel? So an exponent of highest exponent of 1 means it's what? It's linear. So this is not quadratic. The answer here is no. Because it's missing, the highest exponent is, I'm sorry, not missing. The highest exponent is 1. What about part C? Y minus 10x squared equals 9. Quadratic, linear, something else? What do you think? Good, I like the participation. What do you think? 1, 2, 3, 4, 5. Go, what do you think? Yeah, Julia. Quadratic, Cameron?
Quadratic.
Okay. Caesar?
What?
Jamel? Caleb? Why? Why, Danae? Highest exponent is 2. It's right there. Negative 10x squared. That tells you that it's quadratic. So the answer here is yes. Highest exponent is 2. Any questions about that? Any questions about anything? Good, let's see how you do on your own. Checkpoint number 1. Now remember, one of your jobs in my class is to be able to take something that you've learned and apply it differently. Or explore a situation that was a little bit different, but use something that you've learned in the past to try and work through it. So the question is this quadratic? It's a yes or no question, but I would like evidence to support your answer.
What are you talking about? Wait, no. You're right. You're right.
Okay, let's do a survey. Give me a thumbs up if you think it's quadratic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Put your thumbs down. A little over half the class. The function is quadratic because the second differences are constant. So it is quadratic, but the form was quite a bit different than what you had seen. So Andrew, did you have that it was quadratic?
Yes.
How did you figure it out?
I put the ordered pairs in a table.
Oh, that was very well said. So you created a little t-table like this, x and y, and then you just put -2, 4, -1, 1, 0, 0, and so on, and then figured out the differences, and it came out quadratic. Very good. Did anyone do anything differently? Okay. Nothing different? Good. Anyone have any comments or questions? So goal number 1 has been met. Goal number 3 has kind of been met. Goal number 2, the big one, graphing a quadratic. So the graph of a quadratic is a curve called a parabola. That is the term that you're going to need to know. So you're going to have to be able to say that out loud to teammates, to me, to whatever. The curve of a quadratic is called a parabola. But when you draw one, you have to be careful. You have to generate enough ordered pairs so that you can actually see the parabola. What do I mean? Well, let's pretend for a moment that I'm a student and I'm learning and I put this ordered pair and I put this ordered pair and I put that ordered pair, and then I wanted to draw the line. What line would I draw if all I had were those three points? What would I draw? Marlon? You would most likely just draw a straight line through them like this. Because look at that. It forms almost a perfect straight line. So if you do not do your job properly, you actually don't see the picture you're supposed to see. You have to get a broader view. So, in other words, for those of you who are having trouble seeing it, what if this wasn't here? What if that wasn't there, and all you had were these 3 points? It looks like a line. But it's not. It's a parabola. So how do you make sure that you have the right points so that you see the parabola? That's what you're going to learn right now. So, I apologize at the beginning of class. I didn't say you should be using graph paper. If you're not using graph paper, it's fine. You can still do a good estimate of the graph. But starting tomorrow, you need graph paper every day. So we were away from graph paper for a few weeks, but now we're back. So we are going to graph the function y equals -4x squared. So you already know how to do this. Graphing using a table of values has been a method you've used for a very long time. So we just have to figure out how to make sure we get the right points so that we can actually see the parabola. For today, we're going to use a standard domain. What do I mean by that? We're going to use a very common domain that's used a lot. Tomorrow, that'll change a little bit. For today, we're going to use the same one you've seen already. -2, -1, 0, 1, and 2. And what we will do is, just like you did during today's warm-up, get the y values that go with that. You have 3 choices. You can do mental math, you can do paper and pencil math, or do calculator work. Well, however you want to do it, you just got to make sure you're doing things following order of operations, doing the expressions, simplifying the expression properly. So, take the -2, plug it in, simplify, get your output, write it down. Then repeat the process 4 more times. But my advanced students will start to notice something. So, you've got a minute, go ahead and get all the y values, and then we'll come back together. Go. All right, so I'll start us off with the easy one. Can someone give me the y value for x is -2? Caleb?
16.
Double check our work. Sam? Yes, it is -16, so we must be careful. What about when x is -1? Kiera? Is -4. What about when x is 1? Jazz? -4. What about when x is 2? Kiera? Selena? -16. Anybody notice anything? Anybody notice anything? Jamel, your hand shot up right away. Very good. So you will notice that if you set up things properly, if you make the distance here the same as the distance here, these 2 values will mirror each other. And if you make the distance from here the same as the distance to here, these 2 values will mirror each other. In fact, for a parabola, the vertex, the middle, is actually a mirror. This is a mirror right there. And the top will mirror to the bottom. Any questions about that? Good. Now we need to graph. So, I'm going to draw a grid. We need to fit all the way to -16. So I don't have 16 spaces on my graph paper, so go ahead, Rika. Yeah, we just go by 2s. So you got to be careful though, because if you're going to go by 2s, you have to pay attention. But yeah, that's what we're going to do. We'll go by 2s. So this means +2, +4, +6, -2, -4, -6. So if I wanted to go to 1, that would be halfway. So let's plot all the points. -2, -16. -1, -2, -16. 2, 4, 6, 8, 10, 12, 14, 16. The point. -1, -4. 0, 0. 1, -4. 2, -16. Now we made sure that we don't draw a line. We can now see that it's a parabola very clearly. Probably one of the most challenging aspects of graphing quadratics is actually drawing the curve. It is a little bit hard, it takes practice, and it will take you some time. I've been doing it for over 10 years and I still mess it up. I'll probably mess up several all today, but it's easy to just kind of go back or erase and just do it again. It's not a triangle, it is a curve. So it curves from the vertex and it will slowly curve out and it will keep going on and on forever. And it curves from the vertex and it will go on and on forever. Mine is far, far, far from perfect. In fact, I'm not thrilled with my second half, so I'll try it again. It is very difficult to get it perfect. And I'll just leave that. That's the best I can do. And so we have successfully graphed a quadratic. Congratulations. You guys did very well. Does anyone have any questions? Anyone have any questions? Remember that it's a curve. It is not a triangle, it's not straight lines, it's curved lines. Any questions? Good, so we're going to do one more together, and then you're going to do one on your own. But now, since we know what to do, we can go much, much faster. So we're now going to graph the function y equals x squared plus 2. And again, we're going to use a table of values to graph. And we're going to use the standard domain of -2, -1, 0, 1, and 2. That domain will work very often. There's going to be cases where it won't work very well, but we'll talk about that tomorrow. So now, you have about a minute's worth of mental math to do. Plug in each x value, find the y values. Go. All right, so you should have the values. Can someone give me the y values? Someone confidently give me all of them? Go ahead, Essence.
6, 3, 0, 2, 6.
So even though for a quadratic you are required to find 5 points, how many do you actually have to find for real? Danielle? 2. Which 2? Okay. What about this one here? Was this supposed to be a 0?
No.
I made a mistake there.
Oh, it's 2.
Sorry about that. I went too quickly. That's supposed to be a 2. But, so 2 or 3, you really need to find. The top 2 or 3 you need to get. The bottom 2 are going to be mirrors of the top 2. Remember, the y values mirror, not the x values. The x values we wrote in already. So now we're ready to graph. This time, we don't need to go by 2s because we've got all small numbers. So we could just go by 1s. And if you can go by 1s, you should try. It'll make a much better picture if you go by 1s. So we got -1, 2, +6, 1, 2, 3, 4, 5, 6. -1, +3. 0, 2, 1, 3, and 2, 6. And now again, draw a smooth curve through them. I always try to start at the vertex and draw a curve from there. You do whatever you think is best. And the curve does go on and on forever. Does anyone have any questions on how we graph a quadratic? We feel comfortable with the process? It makes sense? Give me a thumbs up if... I'm not saying you're an expert. I'm just saying you feel comfortable with what we've done so far. Good? Good? Some of us? Okay. Put your thumbs down. Does anyone have any questions? Okay, so now I'd like you to do one independently. I would like you to use the table of values to graph this one. We got 4 minutes on the clock. Go.
Thank you.
My, well, same thing that my graphic graphic that I know.
Yes, it's positive. No, what?
Whoever took it.
Yeah. Remember, all you need to really find out is what this one's free.
He's giving me a link to that, so why?
Give those three, and then you get to see.
All right. So this type of question does not lend itself to a lot of volunteering. So let's just get what the graph should look like. Now, I do somewhat regret I did take this from the publisher, and I kind of wish I had done my own because I would have fit in. You should have generated the points 0, 1, 1, negative 3. What is it? 1, negative 2. Negative 1, negative 2, and then negative 2, negative 11, and positive 2, negative 11. So you should have your graph going all the way down here, all the way to negative 11. But you can tell that this is what your graph should look like. Give me a thumbs up if you were successful in drawing a graph. Does anyone have any questions? Now, the next and the last goal, which we already touched on, is that there is an easy way to tell which way the graph is going to open just by looking. You see that this graph opens down. The open is down. This graph opens up. This graph opens down. Did anyone catch what the idea is or what's going on? We got 1, 2, 3, 4, 5, 6 people. We'll start here and we'll go around. Essence?
If the number in front of the x is positive, it goes up if it's negative.
Okay, Raquel? Same thing. Cameron?
Same thing.
We're going to say the same thing. Okay, so they are all correct. When it's written in standard form, and this is key, when it's written in standard form, then this becomes A, that becomes B, and that becomes C. When it's in standard form, A will tell you whether it's going to open up or down. It will open upwards when A is positive, and it will open downwards when A is negative. Any questions about that? So let's explore that for a moment. So tell whether the quadratic opens upward or downward. So we have the function y minus 1/3 x squared equals x minus 3. So just to make sure I'm conserving time, it's quadratic because of that right there. So we know it's quadratic. But the question is, will it open upwards or downwards? Which way do you think it's going to open? Upwards or downwards? Andrew? Downwards. Cameron?
Downwards.
Downward. Anyone else? Upwards or downwards? Juliana? Downwards. Okay. So all of you say downwards. You're doing a great job, except you fell prey to a classic issue, which is that this is not A yet. It's only A when it's in standard form. For it to be in standard form, the y has to be by itself, and then everything else has to be on the other side. Excuse me. We need all the terms to be on the right-hand side. So how can we get this term to jump from here over to the other side? What can we do? Caesar? Very good. If we add 1/3 x squared to both sides, this will disappear, and watch what we're left with. Y equals 1/3 x squared plus x minus 3. Now we can see A. So now, Andrew, what do you say? It's going to open upwards because this is positive. So this function is going to open upward because A is positive. You have to make sure it's in standard form before you proceed. Anyone have any questions about that? I did have another example, but I'm going to forego it. And I did have a couple of checkpoints, but I'm going to forego those because I have another activity that I need to do before you guys leave today. So we're going to wrap up today's lesson. You guys did a really good job. Your homework is on page 417. You're going to do numbers 1 through 6. I'm going to clarify a couple things in a moment. You're going to get the same assignment tomorrow, again, so I don't expect you to finish it because you haven't learned everything yet. Then you need to write down Algebra Nation Section 1, and I'm going to explain that in the next 10 minutes. And then you also must write down that you're going to have a test on Chapter 7, which was a chapter we just finished prior to break, and we didn't take the test yet. You're going to have the test on Chapter 7, not this Wednesday, but a week from Wednesday. Okay? Now, here is the top of the page for your homework. The first two questions, the instructions say, use a table of values to graph each quadratic function. Then describe how each function is related to the parent function. You're not going to do that right now. So don't worry about that second part. You're just doing the table and the graph. Okay? So that part of the homework you can do tonight. A lot of the other homework you won't be able to do until after tomorrow. Okay? Any questions about any of this?